Assalamualaikum warahmatullahi wabarakatuh, and hello to Doctor and my fellow friends. We are from Group 6, which are Bipolar Junction Transistors. We are consist of 4 members, which led by me, Muhammad Saifullah bin Suhaimi, and we have Nur Azma Husna binti Muhammad Azhar, Fazliana binti Zakaria, and Lee Ying Yang. So we divided our topics to 4 sections. The first one is introduction, meaning and background, which I will explain later. Secondly, schematic diagram, advantages and disadvantages. The third one is usage and application. Lastly is the material used. So this is the quote from the famous William Shockley, who is the inventor and the creator of bipolar junction transistor. The quote is: the objective of producing useful devices has strongly influenced the choice of the research projects with which I have been associated. So let's move on to the introduction, meaning and background. The introduction is as below. Bipolar junction transistor was invented in the early 1950s to revolutionize the field of electronics. This transistor is the foundation of computer memories, microprocessors, and other integrated circuits. A bipolar junction transistor, also called as bipolar transistor, is a 3-terminal device that can function as electronic switches or signal amplifiers. So a bipolar junction transistor, or so we call it BJT to simple it down, is a type of transistor that use both electrons and holes as charge carriers. So what is a bipolar junction transistor? What is the meaning of bipolar junction transistor? Simply put, a BJT, we put it simple way, a BJT is a 3-terminal semiconductor device, and the name bipolar comes from the fact that this transistor contains 2 types of semiconductor material, which is positive type P-type and negative type N-type, which the current flows through it. So a bipolar junction transistor usually contains silicon. Moreover, impurities are commonly added to the silicon via doping to make the layers behave as desired. P-type layers in a BJT is to attract the electrons that enter the transistor through its input circuits. On the other hand, the N-type layers encourage electrons to flow out of the transistor. The effect, called as push and pull effect, enables the current to be amplified and controlled between the layers. The configuration of the layers in a BJT determines the electrical current flows and ensures that a charge can return in the same direction as it came. This setup protects the system from overheating, or damaging. So let's go through to the background. The first bipolar junction transistor was invented at Bell Labs by William Shockley, Walter Brattain, and John Bardeen in 1947. The BJT has gone through a number of iterations over the years. Until 1960s, germanium was used in the layers. Brattain fabricated a germanium point contact transistor, bearing some resemblance to a point contact diode. Within a month, Shockley had a more practical junction transistor, which will be described later on. They were awarded the Nobel Prize in Physics in 1956 for the transistor. Towards the end of the century, germanium was replaced by silicon, a material demonstrating more thermally stable, and the speed of the BJT was incrementally increased through the process of doping, leading to the invention of BJT variants such as microalloy diffuse, post-alloy transistors, the diffuse transistors, which, as the name suggests, works by diffusing impurities into the semiconductor, and the planar transistor, which made it possible to mass-produce integrated circuits, thereby kick-starting the consumer electronics boom. So let's move on to the next presenter.
This is the schematic diagram of bipolar junction transistor, and this is NPN and this is PNP. So the difference between these two is the error. So let's look at the error. For NPN, the error is come out from the base, and for PNP, the error is go to the base. So B is the base, C is the collector, and E is the emitter. So let's come to the advantage and the disadvantage. So, the advantage of the bipolar junction transistor, it has large gain bandwidth, it has better performance at high frequency, and it also has better voltage gain. It also has low forward voltage drop, high current density, capability to overlap in 4 regions like active region of saturation region, and it also can act as a switch. So the disadvantage of the bipolar junction transistor is it has more effect of radiation. It has complex phase control, is very hard to control. It has low switching frequency, and it will produce more noise, and it has a low thermal stability.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Azma Husna binti Muhammad Azhar. Number matric D201910888670. Today, I will tell about the usage and the application of bipolar junction transistor. First, the usage of bipolar junction transistor is act as an amplifier, filter, rectifier, oscillator, or a switcher. The bipolar junction transistor will control the amount of the current flow from the base emitter to the base collector in the proportion to the amount of bias voltage applied to the base terminal. Okay, first of all, this is bipolar junction transistor that act as the amplifier. It is because the small change in the base current will cause the large change in the collector current. Next, this is the transistor that acts as a switcher. Bipolar junction transistor, also known as a switcher because no current can flow in the collector circuit in a transistor unless a current flow in the base circuit. The transistor can be switched if the transistor can be turned on or off by changing the bias. Okay, this is the example of the transistor as a switcher. The transistor in the cut-off region will act as an open switching, while saturation region will act as a closed switch. The example of the switches circuit that operate by the transistor is light-operated switches and the heat-operated switches. Next, this is the example of the transistor act as an amplifier. The example is a microphone. The microphone will change the sound signal to electrical signal. The transistor will amplify the input waveform. The application of the bipolar junction transistor is used for high voltage switches, radio frequency amplifier, and for switching heavy current. It is widely used in the electronic industry for equipment including mobile phone, industrial control, television, and radio transmitter.
Assalamualaikum and hi, my name is Fazana Zakaria, the 2019-10 at 65. Today I would like to explain about material used for bipolar junction transistor. Okay, as you can see, Barton and Britton's transistor consists of a silver of germanium, which you can see here on your left. The pictures are 2D pictures here. You can see the green pad is a germanium. With two closely spaced gold point here. As you can see the yellow color. A contacts held in place by a plastic wedge. This is the plastic wedge, the triangle one. Okay, silicon bipolar junction transistors dominate the power device market. The reason is because the low cost of large area silicon devices and the high thermal conductivity of silicon compared to germanium. Silicon carbide SiC has been held as the perfect materials for high power bipolar junction transistors. In bipolar junction transistor contain 3 doped extrinsic semiconductor regions each connected to a circuit. These are the basic steps in the manufacturing process, assuming a wafer populated with single transistor. As you can see here, this is the picture. Okay, the first step is layer 1. Layer 1 consists of heavily doped n-type silicon here. The second process is a lightly doped n-type silicon. Here you can see the color brighter blue, brighter or ultra something like that. Is deposited on top of layer 1, making 2 layers collector. Third step is a part of the collect layer is etched away. As you can see, this is a slightly different shape here because the collector layer, the part of collector layer is actuated to form expression for the p-type base layer. A p-type base layer is added. As you can see on the step 4, there's a pink color here. A p-type base layer is added. Next is part of base layer is actuated, leaving a very thin base layer. As you can see, there is a slightly different in shape to here and here. Next is a heavily doped n-type emitter layer is added. As you can see, there's a blue color on top of the pink color here, and the last step is finally metal connectors. The silver one, as you see, are added, allowing leads to be fixed after testing and separating from the wafer. Okay, this is the final look of the completed silicon planar transistor. As you can see at the bottom, very bottom is a metal collector contact. On top of the metal collector contact is a collector with heavily doped or low resistivity n-type silicon. And then on top of it, we have a collector region near base, a lightly doped high resistivity n-type silicon. On top of that, there's a pink color here, a base, a very thin p-type silicon, and then emitter, heavily doped n-type silicon, and lastly is a metal emitter contact.